All right, I hope yesterday was interesting. Now, focus is a very important topic to talk about, and I know that was a very meaty and, big day, and there was a lot of information, so hang in there. Today, we are going to be talking about the more niche or technical bits of information when it comes to focus. So things like bokeh, hyperfocal distancing, and a few other bits here and there, which I'll throw under a common title of focus because they are all kind of related in some way. But let's begin with talking about lenses again. But this time, the actual physical design of aperture. So, aperture in modern lenses is controlled through the fanning of what we refer to as the blades of the aperture. And it is this coordinated opening and closing of the blades that makes the aperture bigger or smaller. We know this already. However, what I didn't explain is that these blades that fan together actually vary in number, and that has a direct effect on the quality of bokeh you get when you're talking about out of focus areas. See, there's a certain number of blades that make up the fan of the aperture hole, and the amount of blades that make up an aperture on a lens varies depending on the quality, the make, and the model of the lens. Now, very commonly, we see lenses with 5 to 7-ish blades on the lower end lenses, and then up to like 9 or 11 blades for the more higher end lenses. And note that these lenses, regardless of budget, will do bokeh in the same or similar amount in an apples to apples comparison, but the quality and the look of the out of focus blur will be different. And generally, with a lower amount of aperture blades, we can start to see that the bokeh balls actually have a harder kind of shape to them. We can see the shape of the aperture and we can see each corner because that's the fidelity of that aperture. Now, as we stop the blades down, as in we make the aperture smaller, the bokeh balls become smoother and smoother as they get stopped down. However, with a higher amount of aperture blades, such as like 9 or 11, the bokeh balls are very smooth and round, even wide open at f1.4. There are more blades, which means there are less lines in the overall ball shape, and that means that the transition between in focus and out of focus will generally be smoother and a lot more gradual. And generally for most people, this tends to look a little bit more pleasing to the eye, although as with all things photography, it is subjective. Now, all of this is referred to as the quality of a bokeh. And once you start to see these subtle differences, you'll soon start to notice the difference between a bokeh that, a full frame setup produces versus an APS-C setup versus a smartphone with portrait mode on, for example, and so on. Now, there are more advanced concepts if you really want to get into the weeds of bokeh, things like fall off and bokeh shape and whatnot, but they're not super important or relative to the things that we've already covered today. And even things like bokeh quality isn't even all that important when you're at your start of your photography journey, but it is something I wanted to bring up because chances are your first few lenses are going to be made with a couple of considerations in mind when it comes to a purchase decision. And bokeh is usually one of the first things with newer photographers that they gravitate towards because it's sexy. So earlier on, we learned that depth of field refers to an area in your composition that is sharp. And usually that is around the subject of your composition. Now, this zone of sharpness is both in front of and behind your subject. And it is this zone or this field that gets shorter the closer the subject is to the lens and deeper the further away the subject is. Hopefully, we are all pros at this idea already. This depth of field is very valuable to know so that we can both determine the sharpness of our subject, but also so that we can find out the amount of out of focus blur areas that are going to occur in the image as well. However, there is another part with this, something that I want to cover earlier on in this course, even though it is kind of an advanced topic. Now, I want to cover this because a lot of you will dive into street photography at some stage, I'm sure, and this is related to the old technique that classical street photographers used to use. That being said, you don't specifically have to learn this idea right now if you don't want to. It's not at all mission critical, so feel free to come back to this point anytime you feel ready and take it on. So skip on to the next thing if you would like. But what we're going to be talking about is hyperfocal distance. Now, hyperfocal distance is a phenomenon where there are certain scenarios to which when we focus on a subject, every single thing behind that subject, that focus point, can become what's called acceptably in focus. And this is also referred to as focus to infinity. Now, this has a lot to do with adjusting your aperture and your focus point such that you can extend the depth of focus in such a way that it allows for this to occur. So, how does this work? Well, similar to how depth of field works, when we focus on a subject, we're determining the depth of field on a subject both in front of and behind the point of focus. Now, all lenses and all focal lengths at some point have a point to which it's close enough to focus on a subject at the close point of the depth of field, but also the depth of field extends out to infinity as well. Every single lens has this point, you just need to find it. It's harder to see this effect occur at faster apertures like f1.4, but if we were to take an example whereby we used a f8 aperture on a 20mm lens, if we were to shoot a subject that was exactly 1 meter away with those settings, the depth of field would be from 0.63 meters to 2.47 meters. So anything before 0.63 meters would be bokeh, and anything after 2.47 meters would be bokeh. This is depth of field at this particular distance, and we've learned this before, right? But what happens when we move the subject back 1 meter, right? Now, if we're shooting on the same settings, f8, 20 millimeters at 2 meters away, our depth of field suddenly goes between 0.91 and infinity. So everything before 0.91 meters is bokeh, and absolutely everything after that point is in focus. Absolutely everything. This is focus to infinity. And again, this is much easier to see at higher apertures, but remember that there is a relationship between the aperture that you decide to use, the focal lengths that you have, and the distance away from your subject. Also remember that the wider focal length you use, the earlier the depth of field starts to deepen. So f8, 20 millimeters, 2 meters away, and we reach infinity focus with this guess. But actually the true hyperfocal distance, back to the topic of this particular section, is 1.67 meters. The hyperfocal distance is the distance to which you can put your focus point and expect everything behind that point to be in focus. So obviously with this setting, focusing on a subject 2 meters away qualifies because 2 meters is past 1.67 meters. And with this setting, everything past 1.67 meters is going to be in focus. Now, what happens if we change some variables here? Let's say we still use our 20 millimeter lens, but this time we want to shoot at f1.4. What is the hyperfocal distance for this particular setup? Well, unlike our 1.67 meter result for using f8, if we were to shoot it at f1.4 instead, our hyperfocal distance would actually be 9.35 meters. If you wanted everything behind your subject to be in focus with the setting, you would have to focus at least 9.35 meters away. And so you can see a relationship here between what aperture does to the depth of field here, right? On a 20 millimeter lens, the hyperfocal distance, or the point to which everything will be focused to infinity, is 1.67 meters for f8 and 9.3 meters for f1.4. But why is this all interesting? There's a lot of numbers here, right? Why would we use these numbers in this way? And why is focusing to infinity even useful at all? Well, let's take it back to street photographers back in the old days. Back then, autofocus was either not invented yet, or it was invented and it was garbage. And in street, milliseconds matter. And there is no focus speed faster than a manual focus that is already locked into focus. So what photographers used to do back in the day was the old saying of f8 and be there. They would set their apertures to f8, and so long as they were shooting at the hyperfocal distance, so in our 20mm lens example, subjects 1.67 meters away, it meant that they no longer needed to focus because they knew that everything was in focus past the hyperfocal distance. And so if they were using a 35mm focal length, they would set it to f8 and knew that anything that was 5.08 meters away would be in focus. Or better yet, you could use the 35mm focal length and set the aperture to f11 instead, and you would get even closer with a hyperfocal distance of 3.6 meters. And you can start to see how this is really powerful, because when you don't need to wait for autofocus, when you don't need to wait for focus at all you need to do is make sure that your shutter speed is fast enough to freeze the action, and you can snap, snap, snap without a care in the world, knowing that all of your images will be sharp every single time. And they called this zone focusing, and it was hugely popular back in the day. Now, another example of using hyperfocal distancing is in landscape photography. So let's go back to our previous example with the settings of f1.4 on a 20mm lens. If you are shooting a distant mountain, then you know that that mountain is going to be 100% at least 9.35 meters away from you, meaning that if you focus on it, then it and all the other mountains behind it will be in focus as well. And this is extremely useful if, let's say, you are shooting handheld and it's a low light scenario. Using that f1.4 lens will allow a lot of light to come through, meaning that you don't need to use as much shutter speed or ISO, keeping your images clean and noise free. But also, that because the mountains are far enough away, they're going to be sharp as well because they are in your hyperfocal distance. Now, as a general rule, the wider your focal length, the less distance between the camera and the subject is typically required. Usually with wide lenses, we hit infinity focus pretty quickly, whereas with longer focal lengths like 50 or 85 or 100 or 200 and above, it takes quite a bit more distance to get to focus infinity. Also, the higher f-stops we use, the faster we hit infinity focus as well. And then finally, the further away your subject is from the camera, the more likely everything behind them will be in focus as well. Now, of course, everything is a balance, and it does take quite some time and a lot of experimentation to understand the relationship between all of these different parameters. So please make sure to watch this lesson or this section again if you don't understand the theory, but more importantly, go out there and experience it yourself. Alrighty, today we're going to continue with the focus train. So pretty easy. Grab your camera, head outside and set it to the fastest aperture that you can go for your camera. Then pick a subject just a few body lengths away, bonus points if you're out in nature or out in the city, and then take a shot. What you want to aim for here is to have the resulting image have the background still out of focus. Then what I want you to do after that is pick a target that is a little bit further away and then check the background again. And keep repeating this with different subjects further and further away until you reach an image where absolutely everything is in focus. Now, keep this in mind and then focus on something way off into the background and then compare. By keeping your aperture constant the entire way through, but just changing your focus distance and your focus point, you can start to see what aperture and what distance away everything will be in focus. And then you can also do the reverse of this exercise too and shoot subjects progressively closer and closer and closer and closer to you and see the differences in how blurry the out of focus areas become as the subjects get closer to you. Now, like yesterday's assignment and some of the other aperture related ones, this is about the analysis of depth of field and getting used to being able to change it at will and seeing the effects that are occurring when you do so. All right, that's it for today. I'll see you tomorrow.